everyone, my name is Miss Connolly. I started making videos for my students and now I want to make as many as possible for all of you so everyone can be learning math during this crazy time. If you have any topics you want me to cover, connollymathathome@gmail.com. And today for math time, we are going to be thinking about subtraction with fractions. And we are going to be covering when fractions have the same denominator. So you might call this like denominators or the same denominator. But what's important to know about having the same denominator is that you're working with the same size pieces. So you can subtract 7/8 minus 5/8. But if you ever get in a situation where the denominators are different, you have to think about making the same size pieces. If you want to check out adding and subtracting with unlike denominators video that I made, that'll help you understand that part. But today, we're going to stick with this, okay? So let's give a story problem context. Love story problems, okay? So I'm walking and I walk 7/8 of a mile, okay? You're walking and you walked 5/8 of a mile. How much further did I walk than you? Okay, so in that situation, they're asking us to find the difference between the two distances that we walked. So we are going to think about going 7/8 minus 5/8. Okay, so I'm going to show you on two representations. We are going to be thinking about the area model representation, and we are going to be thinking about the number line representation. Okay, so let's get started. On the area model, this is something you did with whole numbers back when you were younger. And just as an FYI, I am only going to be covering fractions. There's a video about subtracting mixed numbers, so if you want to go there, you can. Okay, so let's think about 7/8 minus 5/8. What am I going to do first? I'm going to show all 7/8. And you might remember this from when you were little, that you showed all, and then you crossed off. Oh, sorry, that's only 6/8. Somebody help me. All right, 7/8. And then you crossed off what you were taking away, minus 5/8. So let's see what happens here. Minus 1/8, minus 2/8, minus 3/8, minus 4/8, minus 5/8. And what do we have left? 2/8. So when we are subtracting 7/8 minus 5/8, that is the same as 2/8. Okay, so on our area model representation, you can show all and then cross off. And then we also have the number line representation. Okay, so what I'm going to do first is I'm going to start with 7/8. And I'm starting over here because when we're showing we're subtracting, we want to go backwards, okay? And what I'm going to do is I'm going to show that I've subtracted 5/8. So, minus 1/8 gets me to 6/8. Minus 1/8, 5/8. Minus 1/8 would be 4/8. So I'm going to keep track of what I've done so far. I've started with 7/8, minus 1/8, minus 2/8, minus 3/8. Minus 4/8, and then, that always happens, you need more space, minus another 8 is 2/8. So I'm showing what I land on here as my answer. So let's make sense of this strategy. 7/8 minus 1, 2, 3, 4, 5/8. I end at 2/8. Okay, so we see our same answer there. Another thing that could happen here on the number line is we might be thinking about this subtraction situation a little bit differently. Okay, so I had said that I'm walking 7/8 of a mile and that you walked 5/8 of a mile. And so I'm wondering, how much further did I walk than you? So and if you look at our subtraction strategies for whole numbers, we can add up. That is a strategy. When we're thinking about the difference between two numbers, we're thinking about the distance between them. Okay? if I wanted to say, I'm you for a second, and I'm at 5/8 of a mile, and I want to know how much further did Miss Connolly walk, I would find the distance between these two numbers, the difference between these two numbers. So I might say, I can add up, sorry, those should be the same size. I might say I can add up, so I add 1/8, I get to 6/8. I add another 8, I get to 7/8. So how much further did Miss Connolly walk than me? Let's make sense of this. I started at 5/8. I added up 2/8, and I said the difference between how much further she walked and how far I walked was these 2/8 up here. So when you're using the number line, you really want to make sense of where you're finding your answer. So what is the difference between these two numbers? 2/8. Do you see the 2/8 in this strategy? Okay, so you can add up. The other thing that you might be thinking, like, why isn't she doing it this way? Hold on, I'm trying. Okay, is you might be thinking 7/8 minus what gets you to 5/8? Sorry, there's not a lot of space on this little mini board. Okay, so you might be saying, I want to see if Miss Conley walked here, what's the distance between these two numbers? I might say I'm going to subtract until I get to 5/8. So what is the difference or the distance between these two numbers? 7/8 minus 1/8 minus another 8 gets me to 5/8. So what is the difference between these two numbers? 2/8. And again, we find our answer up there. So it's all about making sense of what, where your answer is going to be in the strategy that you choose. Okay, so if you're finding the distance between these two numbers, your answer is going to be found at the top on the number line. If you did the first strategy where you do 7/8 and subtract 5/8, it's going to be what you land on. Okay, so you have to think about what's going on and what strategy you chose. Some strategies are better for some numbers, but it's important to know all of them, right? Okay, so let's do another example where we subtract fractions with the same denominator. Let's start with 4/6 minus 3/6. No, it's too easy. No, I'm starting over, okay? Let's start with, let's work with tenths. Let's do 9/10 minus 4/10. Okay? So, again, we can think about this story problem context in many different ways. We can say, Miss Conley walked 9/10 of a mile. Sorry, I don't know why I always have to walk further than you. You walked 4/10 of a mile. How much further did Miss Connolly walk? So we're looking to find the difference between these two numbers. Okay? Or you can think about it like this. I've walked 4/10 of a mile. Miss Connolly walked 9/10 of a mile. How much further did Miss Connolly walk? We could find our answer here. Or we could think about that subtraction situation that I just showed, where we're finding the difference between how far I walked and how far you walked. These two would find the distance between. Okay, so let's start with the area model representation, just to review that. Okay, so if you have 9/10, first I'm going to show tenths. Remember, you're making them as close to equal size as possible. It's not going to be perfect every time, especially when we're trying to do tenths on our own. But you do want to make it as close to that as possible. Okay, so you can show all 9/10. There they are, 9/10. And you can cross off the 4/10 and see how many are still left. 1/10, 2/10, 3/10, 4/10. And I see here 5/10 are left. which you might also be noticing is equivalent to 1/2. All right, so that's your area model representation where you represent 9/10 and you take away the 4/10, okay? And then you see what's left over and it's 5/10. Okay? Then we have the number line where you might start with 9/10 and you might subtract 4/10. Minus 1/10 is 8/10. That's my second tenth I'm subtracting, 1/10, 2/10. I'm going to subtract my third tenth, and I'm going to subtract my 4th tenth. So I see that I started with 9/10. I subtracted 1, 2, 3, 4/10, 1/10, 2/10, 3/10, 4/10, and I ended at 5/10 after I started with 9/10 and subtracted 4/10. Okay, so that's one way to show it on the number line. The other way that we talked about already is, and you should be familiar with this from whole numbers, if you want to check out my subtraction strategies with whole numbers, that will help you understand how to use this number line with whole numbers, and of course it'll help you with fractions as always. So if I am trying to find the distance between how I walked 9/10 and how you walked 4/10, I could either subtract back to see how many tenths that I had to walk, or I can add up to see the difference between. So I could subtract back to see the difference between how far we walked, or I can add up. No matter what, if I go this way or if I go this way, the distance is the same, right? So since I'm me, I prefer to add because I think that that's easier to count up than it is to count back. So what I'm going to do is I'm going to add 1/10 at a time until I get where I'm going, which is to 9/10. And notice I'm clearly labeling each jump. So I started at 4/10 and I added 1/10, 2/10, 3/10, 4/10, 5/10 to get to 9/10. So in this strategy, we find our answer where the difference is between the two numbers. Okay? So up here I have 1/10, 2/10, 3/10, 4/10, 5/10. And like I was saying, the distance between these two numbers is going to stay the same. If I was subtracting back, 9/10 minus 1/10 is 8/10, minus 1/10, minus 1/10, minus 1/10, minus 1/10. It would still be 5/10 between the two numbers. Okay, so when you are subtracting with fractions that have the same denominator, you have, well, first you want to check and make sure it's the same denominator because you always want to be working with the same size pieces. Okay, so once you're there, all good. Then you want to select a strategy that works best for you. You also want to be thinking about which strategy helps me the most with these numbers, which one will help me be the most efficient. Okay? You have you have two representation options. You have the area model, where you show all 9/10 and cross off the 4/10. Then you see how much is left, 5/10. Then I also went over the number line, where you have the option of starting with 9/10, subtracting 4/10, and seeing what you land on. Or in subtraction situations, we're finding the difference between two numbers. So just like whole numbers, you can subtract to find the difference, or you can add up to find the difference between these two numbers. So the distance between these two numbers, you can use the number line that way as well. Okay, so I'm going to give you some problems to do on your own, but first, we need to think about what's happening and what will always happen when we are subtracting. okay, with fractions. I want us to think about the two problems that we did. So we did 7/8 minus 5/8 equals 2/8. We also did 9/10 minus 4/10 is 5/10. And if we were just thinking about another one real fast, 3/4 minus 1/4 would be 2/4. So something that's important to understand is what's happening with the denominator, which is the number on the bottom, and what's happening with the numerator, which is the number on top. So let's just look at the denominator each time. What'd you notice? 9/10 minus 4/10 is 5/10. 7/8 minus 5/8 is 2/8. 3/4 minus 1/4 is 2/4. So what I'm hoping that you're noticing is that our denominator did not change. When we talk about 9/10 and we take away 4/10, we are still ending up with tenths, okay? Those pieces that were left are still, they're still tenths. They're still that size, okay? So when I do this, and I have 9/10, I was trying to avoid mixing the black marker with another one, but that's life. Okay, so I'm going to cross off 4 of these. What I want you to notice is that I'm still dealing with tenths. My denominator does not change when we're adding or subtracting fractions. Once you have the same denominator, you have once you have the same size pieces, the same denominator, in your sum or your difference, the denominator will be the same as your, in addition they're called addends, and then in subtraction you have these numbers, and I can't remember exactly what they're called, sorry. So anyways, I want you to notice that your denominator is not changing, okay? So tenths, 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 and you see it, nothing is changing about the size of the pieces over here. Eighths, 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 nothing changed about the size of the pieces, so our denominator didn't change, and then fourths, 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 nothing changed about the size of our denominator, or the size of our pieces, so the denominator does not change, in addition and subtraction. So, the thing that does change is the numerator, because the number of pieces is what we're manipulating here. We had 9 pieces. We took away 4 pieces, now we have 5 pieces left. They're all tenths, they're all the same size, the denominator does not change. So when you look here, 7 minus 5, you can use what you know about whole numbers. I love it. So we have 7/8. The size of the pieces doesn't change, just the number of the pieces changes. We took away 5 pieces that were all eighths, and we end up with 2/8. Look at your numerators here, 3/4. You take away 1/4, you're left with 2/4. Okay? All right, time for you to do a couple on your own. So, get ready to write these down. I would like a representation while you're practicing. Okay, get those representations in your head when you move from 3rd grade to 4th grade to 5th grade, 2nd, 3rd, 4th, all of them. They all build on each other, so you need this understanding to try the next thing. So even if the representation feels simple, I really want you to think about doing the representation, okay? So let's think about 7/8 minus 4/8. So you have 3/6 minus 2/6, 7/8 minus 4/8, and let's think about 8/10 minus 5/10. Okay? Pay attention to what's happening with the numerators, pay attention to what's happening with the denominators, and make sure you have a representation. Okay? Bye.